All right. So geometric sequence, let's see. It's a discrete exponential function. So discrete just means that it's what? What does that word mean when we say discrete? Yeah, points only, no lines. We're not going to connect to them. We're going to leave them as points. Okay. Points only. The terms in the list increase or decrease by a common multiplier, not a common difference, but a multiplier. This common multiplier is called the common ratio, and we identify it by the variable r. Okay. Remember that an exponential function is in the form y equals a times b to the power of x, where b is the multiplier, also known as the common ratio. Okay. Do you guys understand that? Do you feel okay with that? Yes, we can move on. Okay. All right. So the recursive formula. So remember when I write the recursive formula, or when I write any formula and I have to do that beginning term, that initial term, this just says the first term is, this is just some number. That's what K is. It's just some number, okay? It's the first number of the sequence, but just remember it's just a variable, okay? So the recursive formula, you need to have the first term, and then A of n equals R, your common ratio, times the previous term, A of n minus 1. Remember that the recursive formula works on the previous term, what happened before. The explicit formula, A of n equals the first term, A sub 1, times R to the power of n minus 1. Okay, so consider the geometric sequence given by this recursive rule. So this rule has that the first term is what? What does this say my first term is? Say it. 4. The first term is 4. Okay. What are we doing to each term to find the next? This is a geometric sequence. We're not adding, we're doing what? What symbol is that right there? Multiply. So to find b of 2, it says we have to take 3 times b of n minus 1. Well, b of n minus 1 is b of 1, which is 4. So what is 3 times 4? 12. To find b of 3, we have to take 3 times b of 2, but b of 2 is 12, and 3 times 12 is 36. Yeah. To find b of 4, we have to take our common ratio, 3 times b of 3, but b of 3 is 36, and 3 times 36 is 108. To find b of 5, the fifth term, you have to take 3 times the fourth term, and 3 times 108 is 324. You were about to say what? Oh, no, just b of 1, 2, 3, 4, 5. Okay, are we good with that? Yes or no? Okay, so for the second one, number 2, we have to find the recursive rule and the explicit rule from this table that represents a geometric sequence. So what is the first thing that I want to find from my table? Okay, what is g of 1? G of 1 is negative 6. Okay, what else do I need to find? R is my what? Is my common ratio, which is also the multiplier. So what am I multiplying by? I'm not multiplying by 2. I'm multiplying by negative 2. Yeah, I'm multiplying by negative 2. So R is negative 2. Remember that you can take any term. So like I could take 48 and divide it by the term that came right before it, negative 24. And that would give me what the value of R is, okay? Remember that you're just taking one of the terms and dividing it by the one that comes right before it, okay? So R is -2. So using up top what we wrote down as our recursive rule, using this information right here, what is the recursive formula? What is the recursive formula for this? Well, we have to start off with what? Yeah, we have to start off with G of 1. So I'll write that. Sure. G of 1 is -6. And then what do we have to write? Look right here. We have to fill this out. That's our recursive rule. So what am I going to write? I'm not going to use A. I'm using this rule right here. But I'm not going to use A. Instead, I'm going to use G. Right? Do you see that? Okay. So I'm wanting the recursive, not the explicit. So G of M, because that's what's written in our table, equals my common ratio. What are we multiplying by each time? -2 times G of M minus 1. G of M minus 1. That's what the recursive rule says. Okay. Now I have to write the explicit rule. That's right here. This is my explicit rule. So my explicit rule, we're not going to use A of N. We're going to use G of M because that's what's in my table. So G of M equals, let's see, I need to know the first term. What is your first term? -6 times, what is my multiplier? My common ratio, -2 to the power of M minus 1. To the power of M minus 1. We got that? Yay or nay? Okay. Number 3. Consider the geometric sequence whose first 3 terms are given by this. It says, what is the 4th term? Well, the first thing we have to do is figure out what our multiplier is. How am I going to do that? How am I going to figure out what R is? I've written it down like 4 or 5 times. How do we find R? Phone's away. You don't need it out. Divide 12 by -16. 12 divided by -16. So calculators. Here, let's just pass. Calculators. Pass them for me, Zan, if you would. Sebastian, you want a Lorenzo? Says your batteries are low. Okay, we'll put some more batteries in there in a few. Okay, someone take 12 divided by -16 and tell me what you get as a fraction. 12 divided by -16. I said as a fraction. Thank you, Travis. -3/4. -3/4. Okay, so that's our multiplier. Our common ratio is -3/4. So R is -3/4. That's my second blank. So how am I going to figure out the next term, this 4th term? Because that's the first question. What is the 4th term? How am I going to figure that out? Well, I'm going to take the term that came before it, -9, and I'm going to multiply it by -3/4. So someone do that in their calculator. Pardon me? Yeah, the next term is 27/4. The next term is 27/4. Okay. Write the recursive rule for A of n based on the term number. So recursive rule. Look at the top of your paper, your recursive rule. It's written up there in bold at the very top. So what do I need for my recursive rule? I need the first what? The first thing I need is the what? Say it again. The first term, A of 1. Good job, Zan. What is the first term? What is A of 1? It's negative 16. Okay. Recursive rule. Let's see. I start off with A of n. A of n equals, do you guys see where I'm getting this? This is right here at the very top. I'm using this right here. This is the rule that we're using, okay? So I start off with A of n equals, what am I going to do next? R, what is R? Negative 3/4 times what? What does it say? Times what? Finish out that sequence. Yes, thank you so much, Jaden. A sub n minus 1. That's your recursive rule. A sub n minus 1. Now we have to write the explicit rule. So the explicit rule is written at the top right. It's written at the top right. Who feels like they can just rattle that rule off? Because it's written right there for you, up at the top right. Uriah, thank you so much. Go ahead. So hang on, Uriah. What is the first term? Good job. So negative 16 times, keep going, sir. Perfect. To the power of, so you see how I put negative 3/4 in a parenthesis? Because we can't raise a negative number to a power unless it's in a parenthesis. N minus 1. Good job, Uriah. Good job. So it says, what is the ninth term? Well, if I want to find the ninth term, I just plug it into my explicit formula. A sub 9 equals negative 16 times negative 3/4 to what power? If I'm trying to find the ninth term, if n is 9, what power am I taking this to? 9 minus 1, which is 8. You have to write it just like that in your calculator. You have to put negative 3/4 in a parenthesis before you raise it to a power. I need at least 2 people to get the same answer. So negative 16 times, parenthesis, negative 3 divided by 4, close your parenthesis, caret 8. I like it as a fraction. What'd you get, Uriah? Say that again really fast. Over 4,096. Is that what you got, Gianna? Yep. That's a horrible number, right? Thank God we didn't have to figure that out by multiplying. That would have been awful. Okay? Facts. I totally agree. All right, last one, number 4. So number 4 says, you're good. Today's date, 3/1. Oh, time, sorry, is, you knew today's date. It's your birthday. I'm so sorry. Time is 8:45. Sorry, Violet. I'm riding the slow bus today. I apologize. Okay. So it says Dina opened a savings account. At the end of the first month, she had $24,000. Each month after that, she withdrew 24%. This scenario can be modeled by a geometric sequence. So I want to remind you about percent of growth and percent decay. Because remember, this is exponential. This is exponential. So how much money did she start with? Or what is the S sub 1 value? Yeah, she started with 24,000. So this value right here, this is my first term. I need to figure out what my multiplier is. My R value, okay? But remember, when we learned about exponential functions, if you use the percent growth or decay from your exponential functions, if you're decaying, remember that's going to be your multiplier is 1 minus your percent written as a what? What am I doing to my percent? I'm turning it into a what? 24%. I wrote it as 0.24. What did I do to my percentage? I turned it into a decimal. Yes, sir. Thank you. So what is 1 minus 0.24? Anyone? What's 100 minus 24? 0.76. Thank you. Okay. So that is the R value. That is the R value. You have to watch for something like that. That is tricky. And I did put a question like this on your test that has decay because I'm withdrawing money. It's decay. So write a recursive rule to model this relationship. So recursive, let's see. I need to know the first term. Well, S of 1 equals 24,000, comma, colon, whatever. And then S of N equals my multiplier, which is 0.76, that's my R value, times S to the N minus 1. That is my recursive rule. That is my recursive rule. Write an explicit rule. Well, for the explicit rule, we need to start with S of N. So S, and I'm going to put this one like a function. S of N equals, well, what is my first term? 24,000 times what is my multiplier or my common ratio? 0.76 to the N minus 1 power. To the N minus 1 power. So this last part of this says, how much money will she have in her account after 9 months? So that means I need to use this explicit formula. I have to use this and let N equal 9, right? So let's see. S of 9 equals 24,000 times 0.76 to the power of, what is 9 minus 1? 8. So how much money does she have in her account after 9 months? So $2,671 point, just give me 2 decimals. Make sure you round it if you need to. 8. What was the number after the 8? 3. Okay. So she has $2,671.28. She's got a spending problem, it sounds like. Maybe she's keeping a sugar daddy.